The index of refraction for red light in water is 1.331, and that for blue light is 1.340. If a ray of white light enters the water at an angle of incidence of 66.25 degrees, what are the underwater angles of refraction for the blue and red components of the light? So here's what it's asking. It's saying that, and I'll get some the right colors here. We have some water, and then we have this white light. Well, white light is a mixture of red, blue, yellow, violet. So Roy G. Biv, basically. Roy G. ROYGBV. Red, orange, yellow, green, blue, violet. And so if white light is hitting, part of it is going to be a blue light hitting the water, and part of it is going to be a red light hitting the water. And so these are supposed to be my light waves. And whenever they hit the water, the red is going to have a slightly larger angle of refraction than the blue. And so I'm going to overemphasize this by drawing it very obviously different. So we can figure this out if we use Snell's law, and we'll say that N1 sine theta 1 is equal to N2 sine theta 2. Now we're trying to figure out the angle of refraction. So if I have an angle of refraction theta 2, what is that? So I'm going to isolate theta 2. So I'll take the inverse sine of N1 times the sine of theta 1 over N2 equals theta 2. So if you've been following along with all of the questions for chapter 22 on here, then you know how I got this. If you've been following along and you don't know how I got this, please drop your physics class. Now for N1, we're going to use the angle of incidence for air, which is 1.000293. And then for the sine of theta 1, we'll use what's given to us in the problem. It gives us that the angle of incidence of white light for my problem is 60, let me switch back to the pen, is 66.25 degrees. And so that's the angle of incidence for white light. And then N2, the first problem where you want the angle for blue, you'll plug in the N that they give you for blue light. And so I don't know if it's going to change. They should keep it the same, but it's 1.340 for my problem, and then so you'll solve for blue light, and then you'll just change that to the angle of incidence for red light, which is 1.331. And so whenever you do that, you should get that blue light is going to refract at 43.09958. That's with all of my numbers, and red light is going to be at 43.4632. And so just like I said above, red light ends up with a larger angle of incidence just by about 3/10 of a degree. Hey, thanks for watching. Make sure you check out my blog. The link is down in the About section of this video. And on the blog you'll find cool stuff like other videos for the same chapter. And you'll also find little download links where you can download calculators to basically just punch in your numbers and solve these exact problems. So you won't even have to watch the video if you don't want to. The last thing I want to say is if you leave comments on YouTube, of course I will get around to responding, but I'm much faster if you leave them at the bottom of my blog, right down there. Enjoy your day.